All right, the next question for solving via substitution. Again, we can readily recognize now a p minus 5, a root p minus 5, which we could call an x, and a squared version of a square root of a p plus 5, which we can call x squared. So this works out nicely again. So we've got an x squared minus 4x minus 12 is equal to 0. So we can say, well, right, factors of 12 that add or subtract together to give 4 really is only one thing. It's going to be 2 and 6. So we've got our brackets. We've got an x and an x. We know the signs are going to be different. So it doesn't matter which order I put those in. But we do know the biggest one's going to be negative. So it's going to be a negative 6 and a positive 2, which means that either x is going to equal 6 or x is negative 2. Now we want to look at these in terms of p, and we know that we've got a square root of something, but we've also got an x squared. Much easier to deal with an x squared than lots of square roots. So let's just square these two folks. So we can say, therefore we could say x squared is equal to 36, or x squared is equal to 4. Negative 2 times negative 2 is going to be a positive 4. Need sharper pencil, I think. All right. So let's go ahead now and see if either of those two work. So let's test them in order. I've got x squared is equal to 36. By the way, either or both could work, but we just want to find out if which or both of those is true, or neither, of course. So let's have a look. So we've got p plus 5 minus 4 times root p plus 5 minus 12 is 0. And let's try x is equal to x squared equals 36. Oh, we just want to do one more thing. I actually skipped a step, didn't I? I said, well, we're not really testing for x. We're testing to see whether a p plus 5 is that. So I'm going to go back. I made a mistake there. I just missed a step completely. So I got x squared equals 36. So let's go and do that now. P plus 5 equals 36. Could that be what we're looking for? We'll subtract 5 from both sides. P is equal to 31. So that's the first one we're going to test. So it's not x, it's actually p is equal to 31. The other one we're going to test is we've got x squared equals 4. So therefore we're going to say or p plus 5 equals 4. So if I subtract 5 from both sides, we can say p is equal to negative 1. So we've got two things to test, a 31 and a negative 1. Let's test the 31 first. Let's see how that plays out. All right, so I've got 31. I'm going to put that for p here and for p here. Okay, so I've got 31 plus 5 minus 4 times the root of, well, 31 plus 5 is, of course, 36, and root 36 is 6. So I've got here 31 and 5 is 36 minus 4 times, well, this is going to be root 36, and root 36 is going to be 6 minus 12. All right. Does that equal 0? Well, 6 fours are 24, so I've got 24 minus 12, which is 36. So I've got 36 minus 36 does indeed equal 0. Therefore, we could say p equals 31 is a solution. Okay, great. Let's see if we can find whether the other thing is a solution. So I've got p equals negative 1. Let's put that into the equation. Sorry if you can hear dogs barking in the background. So p plus 5 minus 4 times root p plus 5 brackets minus 12 is equal to 0. All right, so let's put the negative 1 into here. Let's put the negative 1 into here. So I've got negative 1 plus 5 minus 4 times the root of, well, negative 1 plus 5 minus 12 is equal to 0. So negative 1 and 5, oh, that's going to be 4. 4 minus, well, negative 1 and 5 is 4. Square root of 4 is 2. So I've got 4 times 2 minus 12 equals 0. All right, so I've got 4 minus, well, this is actually 4 minus 8. So 4 minus 8 minus 12 is equal to 0. So really it's 4 minus 20. And 4 minus 20 is negative 16. And negative 16 does not equal 0. So we know that P is equal to negative 1 is not a solution. So P equals negative 1 is not a solution. So therefore what we can say is, therefore, P equals 31 is the only, I'll put only here, is the only solution. And that's the answer they're going to be looking for.